resolution on a Nodo's giant space. So we wanted to work to develop some kind of an LCD screen overlay, basically, that would work without obscuring the screen. So we decided to try and use some virtually invisible ultraviolet absorbing ink and printing a position encoding pattern that way on top of ultraviolet reflected surface, but that wouldn't obscure the images on the screen. So this is the basic idea of what we've been working toward, and last quarter was basically spent trying to look into the materials and if it was even possible to get the materials. And so this quarter we've got a few things, and we've been kind of working on testing and getting some images to show that we can get a good degree of contrast between the pattern and the background in the ultraviolet range, so that we can work on getting good tracking, which is a problem that earlier studies have had trouble with. So we early this quarter started getting some more materials and looking into some other things we needed. And so we've been kind of waiting on a lot of that stuff, but in the meantime, we've been trying to get some just low quality images to show ourselves that at least we can get the contrast between this the pattern and the background, so that when we do get our new webcam and some of the materials that we're still waiting on, we can start working toward getting higher quality images of a really small dot pattern. So Richard's going to talk a little bit about what we did last week, basically.
Okay, so we created a prototype before some testing, and I guess the first step that we did was we printed a pattern with UV fluorescent ink onto transparent paper. So to the naked eye, the fluorescent ink actually looks gray, basically invisible. But when you actually shine UV light onto it, it has this glowy kind of look. It kind of looks something like that. And the next step we did was we taped UV filter glass, it's actually called wood glass, onto a cheap webcam, so it's like right on top of the camera. And then the next step we did was we relayed different reflective backgrounds behind the UV fluorescent ink printed pattern. The point of this is to create some contrast between the printed ink and the background so we can capture better quality images. Okay, so after we have all that, we shined UV LED light, both with 370 and 380 nanometers, onto the pattern, while simultaneously trying to capture the image with the camera. So this is kind of like the simulation of the actual Enodo pen. And then lastly, we connected the webcam to a laptop, and then we captured the images via the laptop.
So yeah, right now, since we're kind of waiting on a lot of our materials, we've just been doing basic image capture and trying to experiment. And actually, you can't even see it on here. But if you look at the screen here, basically, so what I passed around is this LP400 coated glass, and so it's invisible or it's clear in the visible spectrum, but it's actually reflecting the UV right here. But one problem that we noticed with that is that it's kind of reflecting the UV too much. It's a really sharp reflection. But we got a better diffuse reflection from an iPad screen protector that was on Jawan's iPad. So we ordered another one of those that just came in today, and we're going to try and work on using that and trying to get some images of that in front of some other screens. And it doesn't look good up here on the projection, but if you look at the screen, the iPad screen was actually on like when we took these photos, so it's blocking it from both sides because it's low. So we hope to use that screen protector on some screens that we were noticing were giving out more UV and see if it's still going to block out some of that UV and if we can get a decent amount of contrast. But so moving forward, we kind of are just waiting for a lot of things. We want to modify the webcams that's coming so we can get some macro images. And then we also have a cheap Enodo-enabled pen that's coming, so we want to look at some of the internals of that and see if we can get any more information about some of the image processing components. Ultimately, if possible, we'd like to try to custom fit the LabScribe pen to work in the UV range, but there's a lot of unknowns still about how the image processing is being done. So in the meantime, we want to try and we just started looking into writing a driver for a human interface device for the webcam, and hopefully we want to try and just do some basic proofs of concept, getting a cursor to move around based on what types of light is coming into the webcam when it's filtered. So that's where we're heading for the rest of the quarter. Any questions?